Observatory.
Go.
We are at Dark Ranger Observatory.
So after Bryce, are you going to go support? Yeah, Zion. Kind of an arc. You started in Colorado Springs.
Go.
Tonight we're going to have a tour of the sky.
Domes. I know you got a dome there in the back.
Thank you. We're well here.
You get to the eyepiece, then that's also very helpful. But even if you come over here, you can start with a view of Saturn. And same kind of thing, brass focus knob right here. Go up a step or two on the ladder. And oops, I think the ladder was better where I had it. There. And there's your focus knob right there.
Go.
First I'm going to look at Saturn.
You can focus, but most of the time you don't have to. Just look at it.
Oh wow, I see the rings. Can I see?
Turn around, tell the
I
camera.
want to see. I see Saturn's rings in it. I want to see. Hold the ladder. And you can see Saturn has rings.
Hold the ladder. Do you go up one more? You good?
You see it, Papa?
Okay.
Just look at one eye.
Just
Just
one eye?
And close the other eye.
You see it? Don't focus that.
I was. Can you see it? The moon before? Yeah.
It's the moon, okay?
You know what? Let me go. This is pretty cool. You can actually see the moon really big. Okay, my turn. One side of the moon is bright and one side is dark. Don't touch the telescope. Got it. Well, I see the moon. It's really.
It looks better filming on the other
side.
side.
And then
jump like this.
Pretty amazing, isn't it? It's not a picture, but you're actually looking at that.
I'm going to the other one.
There's actually a website. You can find 680.
And then enemy.
Yeah, I forgot that. Oh, that one? That was called Saturn. Can you say that? Saturn.
I don't think of that.
Saturn. This one's called Jupiter. Jupiter. We have one of the books of Jupiter. Oh, I think I can see the big red hurricane thing. And I can see Jupiter's stripes. And I can see quite a few stars also.
You can.
Yeah.
Hold Mama focus.
My shoes.
Close one eye. Close one eye. Cover one eye.
Yeah, I see the safely.
No,
What is that?
I'm not
Is
sure.
that Colorado?
No.
Here. Go first. Here, cover one eye.
Right, take a look.
He's been calling it onion ring.
Give it a try. More science in it than some. It's kind of designed to college class. So we
don't
talk
wanna
about big and
do
empty
this
universe and
surface.
galaxies and how stars evolve over time, how they're born, that sort of a thing. It's more like maybe a 9th grade level. So what do you think? You want to? For me, when people ask questions, because you know, then I can make sure that I'm here for you. People get nervous. They say, "Oh no, I don't know if I should ask a question because what if it's a dumb question?" Well, maybe you heard the expression, "There's no such thing as dumb questions," right? Probably heard that. I would never go that far. I assure you dumb questions exist. Anybody who thinks dumb questions don't exist clearly has never worked a busy information desk at a busy national park before. That's my day job, and when it comes time to retire, I'm going to write a very, well, I hope, a very popular novel. Not really a novel, but maybe like a tell-all book. That's what they call them these days. Title might be 30 Years in the National Park Service, 1,001 Dumb Questions and the Way I Wish I Could Have Answered Them Then. That kind of thing. And I expect if the sales are good enough, then I'll buy one of these 7-meter telescopes. So when you see the book on Amazon, just know you should come back, because shortly thereafter I'll have some even better hardware. Be careful with white light. Now, some of you that want to take pictures, that's okay. Just make sure you're doing it very discreetly. As photographed here, requires your eyes to be in total darkness for about an hour. And so once we're done with the presentation, we'll be at the telescopes for about an hour, a little bit longer. And even though there's kind of a big cloud bank right in the way, I expect that'll be moving out. And you know, you don't even have to wave if you don't want to, but if you do say, hey, so we're ready to go, then I'll say, oh, wait, stay one more minute. I'll show you some kind of grand finale object. I like to send you home with something cool as your last view through a telescope. And we already covered the questions. Okay, let's talk just for a minute about focusing. So I've created a little simulation here. Well, that's way out of focus. There. So my point is that if you were looking at these characters, which we call English character, which is silly because most of them came from Arabia, are different. Galaxies, exploded stars, starburst nebulae, etc. But if you're looking, and I mean by possibly fast, this one goes way faster than the speed of light. The speed of light is right here as we pass the moon. There, that was it. And we continue to accelerate until towards the end of the animation we're going like 500 million times the speed of light or something like that. Which is ridiculous, I know. But if I did this animation at just light speed, it would take about 500 million years to get through the introductory credits. And nobody has that kind of time. So what we're going to try to do tonight is give you enough background information that you could jump right into your first semester of astronomy. Anybody taking a semester of astronomy by chance? Are there any Douglas Adams fans? Yeah? Okay, some yes, some no. Yeah, and I know. I'm trying to be like one of the 1.5 kilograms. And that's great. That tells you how many atoms are in here. Now, when I talk about kilograms, people say, oh, that's a weight. Well, yes, on planet Earth, mass and weight are the same. But if I was to put this over there at Jupiter, suddenly it'd weigh 5 kilograms. It would still be 1.5 kilograms of mass, but it would weigh 5. Why does it change?
Gravity.
Yeah, more.
Big number.
Oh, and this is millions of tons too, by the way. You know why it's not asked which one's bigger? So which one is bigger?
That one.
This one over here or this one right here?
Which one?
Yes. I eyeballed the heads the other direction. Follow my laser up. This is the moon over here. Okay?
It'll get
So
darker
imagine
and darker.
pulling that little yellow dot.
See his shoe.
317 Earths. The other way we measure the universe is using the speed of light. Anybody happen to memorize this number? I'll take it. 100,000 kilometers is close, but you round it up. Yeah, see, he already knows. Maybe the rest of you haven't figured this out. When I was grading papers in college, I would take off half the points in the exam if somebody dared write 300,000. I would say, I pull out my red pen, you know. This shows a fundamental lack of understanding of what the speed of light is. The speed of light is as fast as anything can go. There's nothing can go faster. Therefore, there's no such number, 299,793 kilometers per second. Who the heck are you to round it to 300,000? It's only 6 numbers. If you can't memorize 6 numbers, how do you dial a phone? 1, 2, 3 planets, you know, they zoom in on Earth because they see the water. Like, oh, this is interesting. Let's use the old name, solar system, with this system. Okay, that's the mass of the sun. It's 98.5% of the everything, all right? Jupiter weighs in a fully 1%. Not bad, huh? That's respectable, 1%. Yeah? I warn you, there'll be a little bit of math. There's a little bit of math in this presentation. See what we're doing? 400,000 asteroids you wouldn't be able to see on this scale. 15 million comets that would be visible but don't add up to much mass. Oh yeah, plus all these dinky little planets here. Add that together, makes the last 0.5% of our solar system. So the sun's pretty big for us. But we compare to other stars, we see that there's a lot bigger stars. Arcturus is this bright star you can see almost straight up right now. Right there. So that's pretty big. But they get bigger than that. Antares, that big star, is this one over right about here in the sky. We'll show you that one at telescope too, because it's really cool. But that one's 7,000 light years away, which is pretty far. And it's huge. The star's physical diameter would be about the same size as Saturn's orbital diameter. Are you with me? So that would mean that Saturn, in its great big orbit, would be about the same size as this entire star. Jupiter would always be orbiting inside the star, you know, Mars, Earth, Venus, Mercury, Sun, all inside the body of this one huge star. Stars are all born in big clouds of gas called nebulae. This is a star birth nebulae. That means specifically place where stars are being born. There's also something called a star death nebulae. What do you think happens in a star death nebulae? Yeah, it's a star that exploded, right? Okay, how about this one? What do you think happens in a Death Star nebulae? Really big words, right? So the question is, hey, how come these things aren't round? How come they're all long like that? An astronomer would go, well, clearly, if you look carefully at this photo, you would see there must be another force in addition to gravity, which would normally hold things in kind of a spherical orientation, influencing these bodies in a different way. Why don't you just say, I don't know? Okay? I mean, if they would have asked a geologist, that's what I was, this would have been real easy. We would have taken one look at that and said, the E word. Erosion, exactly. Yeah, that's what it is. It's erosion. Took the astronomers 2 decades. Can you imagine? Yeah, well, we're really good at math. Okay, fine. But no, what's happening is the energy coming off these really powerful stars, the stellar wind, hits this normally round sphere and it starts washing material away. You geologists in the group have probably done the experiment. We take a ball of mud, pack it really tight, put it in the stream. Every kid's a geologist. And as the stream hits the ball of mud, what do you see floating downstream? Dark cloud, right? The mud washing past, the ball gets smaller and smaller. That's exactly what happens to the stars that are not yet born. First, the 7 sisters, sometimes called Subaru. If you drive a Subaru and you've always wondered why you got these stars in your car everywhere, well, that's because 5 different automakers came together to form one big corporation known as Subaru. And they used that logo from what the Japanese call this star cluster. Pleiades is the other name you might recognize it by. So what I'm going to do is I'm going to tell you the story of stars and how they age quickly. The idea is the biggest stars age faster. The small stars go really slow. So these are the 3 big stars here. They first start out their life as blue. That's when a star is a baby, like a toddler, it's blue. Use that human analogy. When the star gets to elementary school, then it becomes white. Okay? And then after elementary school is high school. That's when the star turns yellow. By the way, if I could just editorialize for a minute, I know some of you are not in high school yet, but the day will come and you'll wish you had this information, okay, about high school, all right? I wish somebody would explain to me. I still wake up shrieking in the middle of the night from my high school experience, but I think if I had known this before, I would be okay. When you get to high school, you're going to meet mean girls, okay, and bullies and jocks, right, in high school. And they seem really cool for those 4 years because they're all big and shiny and bright. But then you know what happens? They age really fast. Once they get out, some of them are going to explode in a fiery death in their 20s. Okay, so it's a little nerds and geeks, you know, like the rest of us that truly inherit the universe. Remember that when you get to high school. It'll be a lot easier. So as they age, they become orange. This is kind of like the adulthood of stars, maybe like age 18 to about 60. When you get into your late 60s, that's when you're a retired star. And after stars are red, then what happens? Yeah, they explode. What's that favorite word of everybody? Everybody's favorite astronomy word?
Boom.
No, it begins with an S.
What?
Supernova.
Supernova. There they are. 3 gigantic stars blowing themselves to smithereens. Want to see it again? That's pretty awesome, huh? Here we go.
Same picture.
There you go. Yeah. Well, I turned it sometimes, and I flipped it, left, right, reverse. Come on, I know how to do Photoshop. Yeah. 50 million light years long. You can't have a picture of your own galaxy. It's impossible. I mean, 50 million light years, you'd be waiting 100 million light years, degrees of horizon, you know, looking from here all the way over to there and back. All the way. What was that, maybe 2%? Kind of a weird thing to worry about, huh? You know, you're sitting around a campfire, people always kind of, you know, sharing their phobias and stuff. Like, oh, I'm scared of heights, or I'm scared of darkness. Poe, what are you afraid of? And I go, well, I'm scared of nothing. And they're like, whoa, tough guy, huh? Scared of nothing? And I'm like, well, no, sometimes when I think about it, it makes me cry. It's so terrifying. And they're like, you're a really weird person. And to build, they built it in 50 different pieces because you couldn't send bigger pieces into orbit and then hook together all the little pieces like Legos. And it has a maximum crew capacity of, anybody know?
12?
6.
6.
Just 6. You're not going to colonize a planet with 6 people, right? So we'd need something a lot bigger. We could never build a big spaceship anywhere near Earth because there's too much gravity here. We would need all the energy planet Earth had to be able to get the thing moving. So, better idea is to build your huge colony spaceship off the back of an asteroid. So, you know, let's imagine we send a bunch of miners, maybe led by Bruce Willis, I'm taking over other planets. Like maybe you just, you know, do the best with the one you got, right? But astronomers don't like that because they're saying, where were the numbers? That wasn't really math. And I'm like, well, doesn't everything have to be math? But anyway, so they love their math though. So there's this game that astronomers play called the Drake equation. And now every 2-bit astronomer, well, including me, has their own version of the Drake equation because of this satellite here. This is the Hubble Space Telescope. But because it's a camera, it can take very long exposures. Your brain will never let you hold an image for more than 1/15 of a second, and then it erases that picture and starts drawing a new one, then it throws it away again, 15 times a second. So you never gather enough light to get that kind of a view. Even if you were to look through the Hubble Space Telescope, and it doesn't have an eyepiece, but even if you did, you still would not see that beautiful high-color detailed image. You would still see something more like what's in the circle. So this will play for about 2 minutes. Just kind of sit and enjoy. I'll steer the telescopes to some new objects, and I'll come back and get you.